welcome back to part 2. When we left off, I was actually starting to show you my test rig, and then it needed some fixing, so I've gone ahead and fixed it. I've resoldered. Actually, while I was resoldering one wire on, another wire came off. That's another thing about these cheap solar garden lights, is that some of the connections are not really that strong, so you got to be a little bit careful as you're working with them. But what this test rig is essentially, let's see if we can pull what we had last time. Here is the one we took apart last time. It's got the circuit board sitting there, and this really has the same circuit board here, and all I've done is I've taken two wires. Let me actually show this to you a little bit better here. We've got two wires that represent the LED and two wires that represent the inductor. And what I've done is I've plugged those wires into this breadboard. Now, a breadboard is a really useful tool for anybody doing electronics hobbying. What I can do is by, I don't know, let's see if I can sort of show this to you. Yeah, it's not going to be too obvious unless you really, let me see if I can twist this around without ripping the wires off again. But you can kind of see that I've got two wires right here and here, and these are the two wires for the inductor. And in fact, if we look down here, you can see I've got an inductor on my breadboard. And so that allows me to change the inductor from one value to another to try and test different things out. I've also got two wires coming from the LED, which is right here. So I've got the two. I've got a red and a black wire. It doesn't matter what color you're using, but you do need to pay attention to polarity, plus and minus. But by running those four wires down to the breadboard, what that allows me to do is things like swapping out the inductor and trying different values, and swapping out the LED. So let me actually recenter this for you. Let's first, well, actually, before I even do that, the simplest thing in the world that you can do, if you've got your unit apart like this, is grab a better battery. Now, this is just an Amazon Basics battery. I'm not sponsored by Amazon or anything like that, but these were just, I've tested these out in the past, and they tend to be good quality batteries. And so I went ahead and bought a 12-pack of these things to be able to replace a bunch of batteries in a bunch of my different solar garden lights that I have, and test a little bit more reliably than I can with the cheaply made batteries like the one here. So let's just say I go ahead and put this battery in the original solar garden light. Now this one, I charged it up. It should be fine. Let me go ahead and switch it on. And there you go. So that light is now working. It's not any brighter than it was before, but this battery should last considerably longer. I have yet to actually run tests on these batteries, but they are rated, I believe, at 800 milliamp hours, which is considerably more than the 60 or so that I'm getting out of these nickel cadmium batteries. So that said, I'm going to go ahead and shut that off, and it's actually swamping out so I can't see the switch. There we go. We got it off. I'm going to move it off to the side. Let's go back to the test rig, and here I've got a red LED. If I tilt it towards you, you might be able to see the LED a little bit better. I can swap that out with another color. It turns out that green is actually one of the most efficient, or at least in my experience, one of the brightest that you will get for the same amount of energy. I'm actually searching for a green LED here. There we go. These are the more recent ones that I happen to have. I'm opening up the package, and since I bought them recently, they're more recently manufactured. I do have some LEDs in my collection that date back probably 30 years. I'll actually show you one of those briefly, but just to give you an idea, this is a red LED. I'm not sure the age of this one. I don't know if it's actually the same batch that I have over to the side here. But red LEDs are actually a little bit more difficult to deal with because they require a different voltage than the green or blue or the white LEDs. So let me pull this red LED out. I'm going to go ahead and put the green in, and I think I got the polarity figured out this time. I really had some problems with the well, actually, maybe what we've got here is we've got a situation where it's not quite bright enough because the inductor is too high a value. So I'm going to go ahead and pull this out, and let's take a look at it. And I don't know how well you're going to be able to see that. I'm trying to look at it separately. It looks to me like it's actually supposed to be a 22 microhenry inductor, and I'm not sure. Well, what I can do is I can pull out my inductors, which are right over here, and I keep a lot of my stuff in these little containers that you know, I cook stuff and I keep the containers. So let's see, I'm gonna pull out, let's see how this compares. It looks like I have actually pulled out previously a 22. Now, I bought a whole package of these and they came labeled like this. It's obviously handwritten, but they come on, I forget exactly what this is called, but they come with a bunch of them, and you basically, this is just tape on the top and tape on the bottom, and you can pull, it's like tape on either side, and you can then just pull them out. I wanted to compare the unit that we pulled out. I'll try and do this. Yep, that looks like it's a 22 microhenry. So that's what I had sitting across these leads here. But just to demonstrate, let me actually put it back. Watch out for these leads here. And oh, I guess I did. If you're not used to breadboards, what happens with the breadboard is this vertical line here, all of these little holes, you can stick wires into those holes or the leads of components into those holes, and all of these holes are connected in each column, but not going left to right, just going up to down. And then across the top there is a long series, a long row of these holes, and those are all connected together. So you can basically put your power supply, you can put one side of the power supply, say the positive, and the negative down here, and then connect wires from that line down to anywhere along here and get the voltage that you need for your circuit. So breadboards were a great invention when they came out. Now let me see if I can stick this in there. There we go. Now that seems nice and bright. Okay, let's. That's with the 22 microhenry. I wanted to show you what the difference is if we switch it. So let me actually go up to, let's say, 100 microhenries. Okay, and so there's that package. And just to demonstrate, I'm going to go ahead and pull one of these off. And let me see, can I prop this up? How can I prop this up? I'm going to take a marker. I'm going to put the marker there so you can get a little bit better view of the actual light. Let me see if I can even tilt it down a little better. Now I'm going to bend the leads of this inductor. And I'm going to pull out. Now you got to kind of remember how bright this is. I'm going to pull that out. I'm going to put in the 100. And you will see that when I put in the 100, you got to get it to line up and connect. Kind of hard to do on camera when you're sitting behind the camera, but there we go. Oh wow, that's actually a lot brighter, I think. So I must have misunderstood. This may not be a 22 that I was actually looking at. This is a problem with these inductors that have a green background. It's really hard to tell what their actual values are. So maybe what I'm looking at when I was looking at this inductor is that that's actually not black. That it should be red, red, black would be a 22. Red, red, brown would be 220. So it'd be a considerably larger amount, and it seems to me like with the 100 this is a lot brighter than it was before. So just to prove a point, let's go ahead and pull out. Now there may be other factors involved, but let me take the 100 and knock it down about in half, and I've got 47 microhenries here. So what I'm going to do is pull one of these out, and I realize the video is starting to run a little long, but I wanted to show you that if you simply change this inductor, now you may not have a whole stack of inductors like I do. You can see I've got them kind of stacking up, and I've got a container full of them here. I bought these for probably about 10 bucks for 120 of them, maybe $8. So I'm going to pull out this 100, and I'm going to put in a 47, which should make it brighter. But it's also possible that there's another part of this circuit that recognizes that the inductance is actually dropped and then compensates for it in another way. But there you go. Now you can see how bright it is. And I think what I'll try and do is in post-production I'll try and put them side by side so you can see how bright one is versus another. So that's that. I'm going to go ahead and leave that one in there. I wanted to show you a couple of other LEDs. You already saw the red. I can pull the green out. Actually, I mentioned an ancient LED that I had. So since we've got this set to be pretty bright, and actually it could also be the battery itself might not have that much of a charge in it. This is an older battery, and I believe I had it charged up, but it may be that it actually discharged on its own. I'm going to pull that green one out, and I'm going to hope, oops, I got the wrong, let me get a different LED. This is what the really old-fashioned LEDs kind of looked like. They weren't clear. They used a red lens to get a red color, at least in part. I'm pretty sure I got into, oh, I got a whole package of them here. See, I had a whole package of them that I had set aside some years ago. So let me pop one of those out. That should be a little fresher, and the leads won't be all mangled like they were a minute ago on that other one. So let me go ahead and plug this one in and see if I got the right polarity. Yep, I got the right polarity, but look, it's not very bright. Because the reality is there's probably maybe 10 milliamps, if I'm lucky, coming out of this circuit. And with the old LEDs, you needed 20 to 30 milliamps to really get them bright. The newer LEDs are much, much more efficient. So I'll go ahead and put that aside. Let's see, let's grab another color. This is another old style LED. Let me grab a yellow. They make them in different size packages. This one here, I believe, is a 10 millimeter package. That means if you wanted to plop this through a hole in a panel, you need a 10 millimeter hole. The ones more like this that I had when I started showing you all of this, this is a 5 millimeter. And this, I believe, is also a 5 millimeter, but you can see it's got the yellow lens on it. I'm going to go ahead and plug that in, and I got the polarity wrong. Thankfully, with LEDs, if you're not pumping too much power through them, if you get them backwards, it doesn't do any real damage. Now let's see. Well, that doesn't appear to have lit up. Let's see what's going on. Let's try flipping it around again. Maybe I got it wrong. Well, see, now we've got another problem. For some reason, that's not lighting up. So I'll have to come back to that. You know, it seems like every video I make, I have one failure or another, and then I come back with another episode. So you know what, at that point, I think this is probably a good point to wrap this video up. I've shown you the basics of what you can do. Oh, the one thing I haven't showed you, really, let me bring the other unit back in, the one we took apart in part 1, and you've got this inductor here, and I probably should you know what, there's a lot of videos out there about soldering, and my soldering technique's not that good, and you probably noticed my hands aren't all that steady either. But to change this out, you can either unsolder it. Basically, you get a soldering iron and you heat up the connections, and then you have to use some method to either pry it out or remove the solder so you can get the component out, and then you can put a new component in. That's if you have more components. The other trick you can do, and I have to do a video on this, on the difference between parallel wiring and series wiring. But let's say this represents, you had 2 of these units and you took one of those inductors out of another unit. Now let's say this is that inductor. If I take this, I can, instead of unsoldering this one, I just unsolder this one, and I can lay it across and solder it on. Now actually I would make it so the leads aren't quite so long, but if you lay it across and they're both the same value, the math works out that you cut the number in half. So if you had 220 microhenries for each of these inductors, and you put 2 of them in parallel, you end up with 110. You've just lowered your inductance and made your circuit brighter. So that is one of the simplest things you can do. You don't even really need a soldering iron. If you really got creative, you could sort of stick this underneath, you'd stick the pins of one underneath, kind of got weaved in there now, and then bend the leads and maybe use a little bit of hot melt glue, and you don't even need a soldering iron. And by doing that, you can cut the inductance in half and raise the brightness. So those are the 2 simplest things you can do to improve improve the brightness. Well, actually, that's the only one you can do to improve the brightness, is the inductor. If you change the battery, you'll probably get longer life because you end up with a more reliable battery than what they usually ship with these things. And the third option is you can actually change the LED. Now for that, you probably have to unsolder it like I did. This unit still has the original white LED. We'll just go ahead and turn it on so you can see, and that's probably coming up as blue, but that's the original LED. And you can change it out. The bluish colors tend to work best. White is actually a blue LED with a filter on it. Green is very similar to blue, so you end up with similar characteristics in terms of brightness. Once you get down to the reds, the oranges, and the yellows, you have a change in voltage, which actually doesn't affect this circuit. It'll still work, but you have to pump more power into it to get the same amount of brightness. So with that, I will now wrap this up. In the next video, we'll talk about some of the more complicated things you can do to improve your solar garden light.